So this is a trick for u substitution. Sometimes when we use u substitution, we grab what we're supposed to grab, like this, and then we find our du is just plain old dx. And so when we plug it in, we end up with this. And you go, okay, the x didn't disappear. We still made it better. See, right now we have a quotient rule going on here. So trying to work in reverse of quotient rule is just a pain. So what we've done now is converted the bottom to a u to the fourth. So what we still have is a function here that we can use, an equation that we can use to replace the x. The x is equal to u minus 2. So if you solve this equation for x, you get u minus 2. You can then now replace the x as well. And you may think, well, it's still a quotient. Yes, but it's something we can simplify. So this becomes u over u to the fourth minus 2 over u to the fourth. It's because we have now turned it into a division with one term, not that massive thing that we have here. So now we end up with the integral of u to the negative 3 minus 2 u to the negative 4 du. They're general powers. So we end up with u to the negative 2, negative 1/2, minus 2, u to the negative 3, negative 1/3, plus c. And so now we just need to do a little bit of rewriting to get it back to where it's supposed to be. So this is negative 1 over u squared plus, forgot the 2, plus 2 over 3u cubed plus c. And so we can put it back together with a little multiplication into one fraction, but we got that constant off to the side anyways. Let's just leave it. So this is negative 1 over 2 x plus 2 squared plus 2 over 3 x plus 2 cubed plus c. And there you have it. All right, let's do it again, just so you can see that it works every time. So again, we're going to take u equals x plus 3 because it's the denominator and it's in a cube. So you always want to pick the one that is in the worst position, that one. Du equals 1 dx, so again, a straight replacement. So we would have x plus 5 over u cubed and then dx. So again, we can come back over here and go, okay, well, x is equal to u minus 3. So if I replace it, I get u minus 3 plus 5. Oops, that's supposed to be a du now. Du. Simplifying that, we get u plus 2 over u cubed du. And now we can split it. So this would be u to the negative 2 plus 2u to the negative 3 du. And so this would become u to the negative 1. So that would be negative 1 plus 2 over and u to the negative 2. And so negative 2 down there as well, plus c. And so this is negative 1 over u minus 1 over u squared plus c. We can then come back, plug in our u. So negative 1 over x plus 3 minus 1 over x plus 3 squared plus c. And we have our integral.